So topic is anomaly. Book Bipin Kumar book. Okay. So now what we do it we will be knowing what is outlier and then few popular techniques for outlier detection. Okay. So here some example here. So what are anomalies or outlier? So the words anomalies and outlier will be used interchangeably. So therefore you should not confused about the word anomaly or outlier. So in this context we'll be using as a synonym. So one to other. So what are anomalies? The set of data points that are considerably different than the remainder of the data. So here we go. So suppose if you see on the right side, there are some clusters as you can see, but there are some point also you can see. So those points are actually quite different from the rest of the points because these points are in some isolated regions. What is this point? This point is nothing but an object. An object consists of features that is initial first class we said. So let's say any object, so let's say weight and height. So then that can be plotted. So weight and height of an object, okay, can be plotted over two-dimensional space, Euclidean space, and we'll get on the right side. So there will be some points which is not matching to all other points. Let's say this weight and height of the human being across the world, across the country, across the region. There may be some of the guy in some region, okay. So maybe weight and height is totally different. So height is say x-axis is let's say it is weight and y-axis is height. So it may happen this scenario, okay. So now you need to observe. So earlier we mostly in clustering approach we focus set of points which form a regular pattern. Okay, so these are the set of points here. But in anomaly detection study, we'll basically focus set of points which are not forming a regular pattern or cluster. So in this example, you can see this point, this point, this point, even this set of 3 points and this another points. So these points are called the anomalies. Okay. So natural implication is that anomalies are relatively rare. As you see, if the number of points in this region you see so dense, it may be 1,000 or maybe say let's say 10,000 points in this region. But if you see in this region there are only 2 points. So therefore natural implication is that anomalies are relatively points in a data here also important. Okay. So let's say freezing temperature in July. Okay. So suddenly if they see, let's say if let's say 40-degree temperature in summer is quite normal in Raurkela. Now if you see in December or say end of December, if you see 40-degree or 45-degree temperature in Raurkela, so it has a different, that is very rare. Okay. So that type of event is called the anomalies or outlier. And very frequently, let's say if 3 o'clock night AM, if your friends call you and say ki how are you, so that is very rare case that someone will call. If someone calls means you need to realize that something not very what is called is it does not follow the regular pattern that call around 3 o'clock and say ki how are you. So these are the what is called the events can be considered as the anomaly or outlier. Here these are the objects are called the anomalies or outlier. So one example is like this can be an important. Okay, important might be say 3 o'clock if someone is calling means you don't know what may happen in the morning, what you can hear what something wrong. Okay, so it has an importance. Let's say credit card transactions suddenly overshoot some your transaction limits. Let's say your regular transaction values. So suddenly you see you have a transaction of 2 lakhs. Okay, so therefore it has a implication of financial loss and any other part. So therefore it has an important and then maybe a nonsense also, nuisance. So therefore this is one example is unusual high blood pressure. Okay, and then this 10 feet for tall guy is having weight of 2 years is having 10 feet tall. So here is stories like that, ozone depletion history. So here is it is found that in a Antarctica region, so it is surveyed by human being, that is British Antarctic Survey. They showed that is there is a drop of 10%, what is called 10% ozone level drop in the from the normal levels. But there is some dedicated satellite to observe it, but that satellite is not observing this behavior. So finally, what is found? So actually, satellite is controlled by a program. That program basically, because it is below 10%, so that is negligible, and that is considered as a noise, and that is removing. So therefore, this may be very alarming situation, and but due to the computer program, so it is not keeping track of that particular event happen. So therefore, it depends on the context that whether you want to use or whether you want to see those outlier or what is called anomaly events or not. So in this example, let's say in DB scan, what you observe key in DB scan, what we see key if the point is what is called is noisy point. Okay, so simply we are removing those point as a noisy point. But among the noisy point, there may be a point which is an outlier. So outlier means outlier noisy point is different and outlier, but obviously due to noise there may be a outlier also. Okay, so so therefore it has an importance, as I said, key transaction limit or regular transaction exceed in a particular day is above 2 lakhs. Okay, so that may be one can ignore is like this guy is regularly he has transaction of 10,000, so this may be something different. But if you have a interest to know that what happened, so then ignore noise, it ignored the outlier as a noisy point as DBScan did. And other direction of research is like finding only the anomalous activities. So they are not interested about the regular patterns. Yes.
So, what is the difference between noise and outlier?
Hmm?
So what is the difference between noise and outlier?
Okay, it has one slide, I think it will come here. Okay, noise mostly happen due to erroneous part. Okay, so let's say, and that is random. Okay, but outlier is like natural. Okay, outlier. Let's say in dam water level in dam is generally say 7 feet, but if due to flood and something that may raise to let's say 9 feet. So this is not this reading is not a noisy reading. Okay, so this is actually it naturally it happened. Noise is like random fact. Okay, this is one example I can tell you immediately. Okay, so here cause of anomalies, data from different classes measuring the weights of orange, but if you grapefruit are mixed in, so this grapefruit might be a noise also. Okay, so natural variation and data error and so on. Okay, these are the maybe few cause, but as I said ki due to noise also there may be some anomalies point, but there is a clear distinction along with that ki as I said gave you the one example or what is noise and what noise. Anomalies, noise is erroneous, perhaps random values or contaminated objects, so that is something called noise. Okay, noise does not necessarily produce unusual values or objects. So what we did, noise generally happens. So let's say reading noise in reading when you take some reading of some experiment. Okay, so there may be also there may be a chance of error also. So that can be treated as a noise. Okay, and noise is not interesting. Generally, we are interested to remove the noise. Okay, so but as I say in DB-scan, we are removing the noise, but along with removing noise, okay, we are also removing the some outlier points. So as noise and anomalies are related but distinct, it has the distinct concept, as I said one example. Okay. So general issues, number of attributes, many anomalies are defined in terms of the single attributes. Okay. So that is height, shape, color, and so on. And it is really a hard problem if you have multiple attributes. And an object may not be anomalous in any one of the attributes, but if you see overall, it may be another what is called is anomalous. So therefore, in multidimensional data, where you have a multiple features, detecting anomalous activities is not very easy task. So, but if you have a height, so you are asked to find the anomalous guys or the outlier events. Say you got a mask. Sorry, what I say is the height of students in a class. So if someone height is quite what is called is lower or higher than some average, then obviously you can easily identify. So therefore, using only a single attributes, if you have a data is having single attributes, the task is much easier. But whereas if you have a multiple attributes and their value of range is also different, so then it is very challenging to find the outlier. Okay, so many anomaly detection techniques provide only a binary categorization that an object is anomalous or not. So if you are given 10 objects, so then each one will identify whether it is a normal object or it is anomalous object. So one can use for the classification technique for identifying whether it is anomalous object or it is not. But as you understand that anomalous object or anomalies are very rare, so therefore you need to face the challenge of data imbalance if you go for the classification technique, okay, or supervised learning technique. So other approach as I point. So this is the technique. And then based on the score, we identify the point is anomaly, and if it is anomaly, so what degree this point or object is anomalous or not. So you often need a binary decision. Should this credit card transaction be flagged or still useful to have a score? Okay, so both are quite uh, useful in many applications. But as you understand, as I said, if you go for the classification technique, you need to handle you need to address the data imbalance problem. Because say let's say in a data set, there may be a chance of only 1% data is anomaly. Okay, so now if we have a data of 199 data, 99 objects from the normal and one objects from the anomalous activity. So now how do you make the model in case of the classification technique? That is really challenging task. It is not only data imbalance. You can see the other part, that is the anomalous or outlier class is very less. So therefore, there is issues like find all the anomalies at once or at a time, and then evaluation. How do you evaluate? Okay, how do you measure the performance for supervised or unsupervised situation? So that we need to look into, because see in case of the classification we use the accuracy. Okay, and as I said earlier, is accuracy is having severe drawbacks when the data there is a data imbalance issue. So then you cannot use the technique is called accuracy. Then we learn the other technique is called supervised, precision and recall. Okay, and precision recall also we need to know the class level. Okay, so obviously, then how do you find the what is called how do you evaluate the anomaly detection technique? Okay, so that is another challenge here, but obviously we use for precision and recall. So, but precision is something we can say, or recall we can say detection rate and so on. But in general, this technique also use the precision and recall. And then there are other important part we missed in classification technique is something called is the false positive. Okay, so false positive rate, false positive. So false positive is really important here because let's say you have deployed a anomaly detection technique for credit card transaction. In credit card transaction, say let's say if 20% of the total transaction in a day say key is anomaly, then is also a really headache. Out of 20%, it may be only the 1 or 2% are actual, what is called actual fraud transaction. Now what you have to do out of this 20% transaction, you need to check which one is really fraudulent. So therefore, there got the false. So this transaction is outlier. So therefore, you for a perfect what is called is outlier detection techniques, one should look into also the false positive rate, how to reduce the false positive rate. So therefore, any algorithm also it does not report only the precision on recall, it also report the how much less is the false detection, that is the false positive rate or false positive. So here is the definition of anomaly detection problem, that is we generally follow here. Given a dataset D, find all data points X with anomaly score greater than some threshold T. Okay, so you are given a set of data and then what you have to do, you find the anomaly score for each point in the data, and if anomaly score is greater than some threshold value, so we can consider those points or those objects are anomalies or outlier. Given a data set D, find all points X having the top 10 largest anomaly score. Here is above some threshold, all points you say. Here you say is you give me the top n points, which your algorithm says ki this will be the top n anomalous point. Okay. Given a dataset D containing mostly normal points and test a point X, compute the normal anomaly score of X with respect to D. So you have only the normal points. You don't know. See, earlier what we are saying is whatever the data is given, so that will be mixture of normal and abnormal points, and you pick only the abnormal points. So here it is considered that you have only the normal points, but question is who will give you that this data only is having the normal points. So now if you have only the normal point, now given a test data set, you need to say whether this data is normal or this data is analog, so it is called anomaly or outlier. So this is one example here. You can see model based. Okay, so this one, and then model based anomaly detection, build a model for the data and see. This is there, as I said, key unsupervised techniques are more popular than the supervised techniques. Data set. Even we say is that anomalies are very less with compared to the normal points. Let's say in 1% case. So you have only one, let's say 1% case. Then what will happen? So or maybe 2% case. what will happen? One will go in the training data set and another one will go in the test data set. So this is really very challenging for developing the what is called is supervised learning model for the anomaly detection. So, but on the other hand, unsupervised techniques we have so many options, especially the these techniques, that is statistical techniques, have been used for long. So let's say in more than 100 years, and then state of the art work is like you use anomaly detection or clustering techniques or graph-based techniques and so on for finding the what is called is anomalies or outlier. Okay, so yeah, proximity based. So anomalies are points that are far away from the other points. It can detect with graphically in some case. And then state of the art work is the density based. Here assumption is anomalies generally located in low density region. Okay. As we said, in if you carefully observe in case of the density based clustering is defined as the is the dense region and separated by the sparse region. Those are the cluster point. So therefore, indirectly it is saying, as we know that cluster is quite opposite to the outlier points. Cluster points are opposite to the outlier points. So therefore, from that definition, one can conclude that outlier points basically it locates a outlier point because it is not following the pattern, and if you see the distance, consecutive distance from the points is quite lower than the points from x to the other points. So this point is the outlier points. Okay, and then there is a statistical approach. So statistical approach, it has been used for a long time. So it basically computes some statistics like mean variance and then other thing, and then finally it concludes the point is outlier or not. One example might be good idea here. What is done, you assume the data follow the Gaussian distribution, and then this is one dimensional Gaussian distribution, that is only one features, and the points which are in this region, that is above 2.5 in this region, so that will be the outlier point. So that is the one statistical approach. Okay, so this is for one dimensional, and then maybe it can be extended for the multi-dimensional point. Here there is something called statistical approach. So what we will see is if the point is far away from the normal point is considered as the outlier. Okay, so this is nothing but the mean of the data, and then this is the new points, and you take the max, and that will be deciding factor for whether the point will be outlier or not. So there are some other statistical techniques, I am not going here, but there is a problem with the statistical uh, techniques, that is it assumes the data will follow a particular distribution. Okay, but in reality it may not happen, and because see, if you draw only for a distribution for one dimensional, two dimensional, so therefore it may not be applicable for the multi-dimensional or multi-valued features. Okay, so these are the problem for statistical approach. So therefore, statistical approach hardly used for anomaly detection, but one can use the statistical approach with mixing or combining with other approach. Now come into 1998, that is the distance-based approach. So there are several techniques for distance-based approach, but in 1998, Noor proposed uh, a technique that is maybe extended version of the statistical approach. So he gave the definition, that is an object is an outlier if a specified fraction of the object is more than a specified distance away. Okay, so based on that, he has say what he wanted to say key. So one object will be considered as an outlier if that object is quite far away from the rest of the object. So then rest of the objects and other thing is quantified using the specified fraction. Specified fraction means an object as a outlier if so, and then I mean distance that within a specific distance. Let's say one point will be considered as an outlier if 80% of the other points will be away from this point within a distance, let's say 10 meters. There are, if you see this definition, there is two parts. One is a specified fraction of the objects. That means if you have a 100 objects, so an object is an outlier if 80% of the object is more than a specified distance. Let's say specified distance is t. So away from the objects. So then that object will be considered as an outlier. Did you understand this part? So there are two parts. One is specified fraction. Let's say specified fraction, I wanted to say, let's say 80% of the object will be away from the object. And how far away? That is also will be defined. That is something called the specified distance, or maybe is more than a threshold distance. Okay. So instead of the specified, we can write a threshold distance away. So this definition is quite famous. Then outlier score of an object is the distance to its k nearest neighbor. Okay, so this is another direction is as I said, key problem can be tackled in different way. One is like saying that this object is outlier or not. Another way, key for each point there will be a score, and based on the score we can say key whether this point is outlier or not. If its score is high, then we can say outlier is more, so therefore this point will be outlier or not outlier, and the rest of the points will not be said key outlier. So outlier score of an object is the distance to its kth nearest neighbor. Now Noor also gave in the same article, say for each point one can identify the outlier score. What is outlier score? It is nothing but the kth distance of the points. As you understand what is kth distance, kth closest distance is called the kth nearest neighbor distance. Now if the point is outlier point, so therefore its kth nearest neighbor distance will be far with compared to the points which is a, if you yeah, let's say this is a point here. Okay, whether this point is outlier or not, how according to Noor definition. So what we have to do, the a specified number of fraction of the point, let's say these are the 80% or 90% of the object will be away from this point, and away is how far it is away, it is some threshold distance. So 80% of the object will be away from a specified threshold distance. So that is, so therefore this point will be considered as an outlier. So we know that is the definition of outlier is probably the point which does not follow the, this point will be different from the rest of the point. So they define it, they quantify it. How do you how do you say ki the point will be different from the rest of the point? So that Noor gave the definition that 80% or 90% pre-specified fraction of the point will be away from the given point. Let's say we consider this point, or we consider one point from this region. So if I say 80% of the point, obviously 80% of the point within this region, and then some threshold distance. This is maybe the threshold distance. So therefore, many points. It is not 80% point. So at least say 50% point will be within the vicinity of this point. So therefore, this point should not be called as a outlier. So this is the definition of Noor. Okay. So, and then as I said, key outlier score is nothing but the degree of outlier is defined as the kth distance of the kth neighbor distance. Okay. So here we have a set of points. As you can see, the D point is the outlier. Okay. Now what is done is for each point, k.
Switch.
So each point you compute the kth neighbor. So here k value is 1. So you find the closest point here. For all point you compute the closest point and you plot it. Okay, for highest to lowest. So for this point, this may be the closest point. So this distance is, let's say, 2 unit. And similarly for, let's say, for this point maybe the closest 2 points, so this distance will be 0.4. So these may be considered as the outlier score. For this point outlier score is 2, and for this point is outlier score is 0.4, and then you choose the top few points as the outlier. Let's say is the here, this point also may be treated as outlier because its k nearest neighbor, that is k value is 1, is also quite high. Now you move to the this diagram with 2 outlier, okay, and then 1 nearest neighbor. So now this point no longer will be the outlier. This point also will be the outlier because here you will have a 1 nearest neighbor and then maybe 1 will be taken. So still this point might be, no, I think, yeah, there are 1 nearest neighbor. Okay, let me rephrase it. 1 nearest neighbor but 2 outliers. So 2 outliers is where. So now this point will not be no longer the outlier because we are taking the 1 nearest neighbor. So here distance, whatever the distance, there may be some, this distance also quite same as this distance. Okay. So therefore this blue point is locating here in this region. So outlier score is very less. However, this red point is somewhere here because we are taking the 1 nearest neighbor. So 1 nearest neighbor might be this distance. Okay. So it is locating somewhere here. Okay. And green is this region. So this will be in this region. So therefore, if you have a 1 nearest neighbor and we have, results will be different if you change the distribution little different. Okay. Now, if you consider the 5 nearest neighbor, okay, so you will get the different way. So therefore, what we see is this type of algorithm is quite sensitive for the kth nearest neighbor. What will be the value of k? Okay. So this is one more example. And obviously expensive because you need to find the nearest neighbor of each point. So complexity will be order of n square, and sensitive to parameters and sensitive to variation in density. Yeah, this is another issue is if the data set varies heavily, like DV-scan, it also cannot work. So, okay, this technique, that is node technique, is cannot use only the computing the what is called is kth distance. The inverse of the density around the object. So if the density is high, then that point is no way it will be the outlier. Okay. So if the density is less, that point will be the outlier. So therefore, outlier score of an object is the inverse of the density around the object. So what we can do it is directly inverse to the density around the object. So that is followed in case of the density based outlier technique. So now question is, how do you define the density? So can we define in terms of the k nearest neighbor? So inverse of the distance to the kth neighbor. So now how do you define the density? What you take is earlier directly outlier score, we are taking the kth distance. So instead of kth distance, what you can do, take the inverse of the kth neighbor distance. So that will give you the density because distance is more means if you take 1 by k, so this value will be very less. So that means that point will be in a sparse region. Okay. Another definition can be inverse of the average distance to the k nearest neighbor. Instead of taking only the kth neighbor, so you can take the average k nearest neighbor distance. Okay. So and then DVs can also you can follow, and then you can identify the outlier point. But problem if there are regions with different densities, this approach can have problems. As I said, only if you take the k nearest neighbor, and main problem is how to fix the value of k in case of the unsupervised learning. Okay. So therefore, there are many techniques. Mostly they don't focus on the how to fix the value. So they say key value can be fixed with different range of k, and then initial work may only they focus that assume that value of k will be given or it can be extracted from the data set, and then move on developing the new what is called outlier detection technique. So another example is like consider the density of a point relative to that of its k nearest neighbor. What you do, you find the density and then you take the average of the density of the point. So with k is the what is called k nearest neighbor. So average relative density of the point x with respect to the parameter k. So what you do, you find the density of the point and then you take the average density of the neighborhood. Because if you see the for the outlier points, neighbors is quite far away. Okay, and those neighbors might be a data cluster points, and when you take the average, so this value will be quite low. Okay, and then therefore what happens? So we can identify the average relative density of the points. Now I'll talk about density-based technique, and I'm continuing to telling about the density-based technique. But next approach will be quite famous. So is something called is LOF approach. So density-based approach. Here is LOF is full form is local outlier factor. So this work was introduced in 2020. Sorry, 2000 only. So it was published in SIGMOD. This is really a what is called a seminal work in outlier detection. Still people are using, or if you want to develop some outlier detection technique, you need to compare with this results with this technique. Technique because P2 is very close to a dense region. However, P1 can be considered as the outlier because P1 is quite far away from the. This is one cluster. This cluster is very sparse, and this cluster is very dense. Now, if you fix like distance from the sparse cluster, distance between 2 points is same as the distance between P2 and then the closest point from this cluster. So therefore, if the density varies heavily, the traditional approach before 2000 techniques, they could not identify the outlier effectively. So they came up with an idea that if the data set varies heavily also, they can identify the outlier effectively. So that approach is something called local outlier factor. Okay. So local outlier factor basically it based on the 3-4 definition. So I need to tell those definition, and basically it identify the density of the neighborhood, and then it says ki whether the point is outlier or not. So let's say whether P2 is actually a outlier point with respect to its neighbor. Okay, but if you consider the average distance between these 2 points in this cluster is same as the distance from P2 to C2. So in this scenario, they define some terms. I need to define those terms here. Okay. And then there is something or cluster-based technique. LOF. Okay. So I will directly share the paper with you. I don't know. I have only 5 minutes. Okay. So hopefully you can see my screen, and then there is a paper is called LOF. So I can show you the paper here. So it is LOF, identifying density based local outliers. Okay, this paper was published. Yeah, this is quite good name in so University of Munich and the University of British Columbia. Okay. So here paper was published in SIGMOD. I don't know why mod, it should be SIGMOD. Okay. So now we go to the few definition here quickly. I don't know whether I can complete it. Yeah. So there is something called k-dist of an object P. What is k-dist? K-dist is nothing but the distance from the point to the kth nearest neighbor. So that is something called the k-dist. Okay. So that means how do you do it? You find the distance from a point to the all points in the data set, and then you choose the k closest point, and what is the distance at the from the point to the kth point. So that is something called the k-dist. Okay. So once you define the k-dist, now you define the k-distance neighborhood of an object. So k-dist neighborhood of an object is nothing but the all objects which are within the k-distance. Okay, so n-k-dist of the object is nothing but the all set of points excluding the point itself which has the distance within the k-dist. K-dist means distance from the point to the kth nearest neighbor, and then all neighbors within the k nearest neighbor is called the k-dist P. Okay. Now we have to define what is the reachability distance of object P with respect to the object O. So reach dist of a point P with other point is nothing but the distance from the point to O, otherwise k-dist of point O. Okay, so that is something called reach dist. Okay, so once you define the reach dist, then we have to define the local reachability density of the object P. What is the local reachability density, or LRD? While computing LRD of a point, what you have to do, you have to find the all its nearest neighbor. So that is the all its nearest neighbor, and then what you do, you find the nearest find the reach distance of the all nearest neighbor points. So what is the reach distance of P with respect to all its neighbors? So I repeat it. Suppose I want to find the LRD of a point P, then what I have to do? I have to find the all its nearest neighbor, and then among the nearest neighbor you find the reach dist. Reach dist is defined here. Reach dist is nothing but the distance from a point. Yeah, distance from a point. Reach dist of a point P with respect to O is nothing but the either you take the distance, direct distance, or you take the k dist of the point P, and then you take the maximum one. Once you define the LRD, then you define the local outlier factor. So local outlier factor is nothing but the you take the average LRD of O. O is nothing but the nearest neighbor of the point P, and then divided by the LRD of a point P. Okay, so I will show you one example here. Yeah, suppose you want to compute the local outlier factor of the point P, and then local outlier factor, if the point is really outlier, then obviously LOF value of the point will be far greater than the value of O, value of 1. If it is close to 1, then actually it is a cluster point. Now come to the point here, how do you find the LOF of this point? What you have to do? First task, to find the LOF of this point, you have to find the nearest neighbor. So here nearest neighbor, how do you find? So minimum point is 3. That means k value is 3. So now there are 3 points, 1, 2 and 3. So you identify the 3 points. Now if you go to the definition of LOF, what you have to do, you have to find LRD of this point. So here we have the definition. Okay, LOF of a point, what you have to do, you have to find the neighbors of the point. So we identified the 3 neighbors, and now for each neighbor you have to compute the LRD. What is the local reachability density? So that therefore here we identify 3 points, and for each point you have to compute the LRD. What is LRD? LRD is local reachability density. How do you compute the local reachability density? In order to compute LRD, you need to know the reach distance of the each neighbor. So these points, there are neighbors is 3 points, 1, 2, 3. For this point, this will be 1, 2, 3. For this point, this will be 1, 2, 3. For each point, you have to compute the LRD. What is LRD? LRD is nothing but the reach distance. So therefore, all its neighbor, you compute the reach distance. What is reach distance? Reach distance of this point is nothing but the distance from here to here or its neighbor. So you have to have also the neighbors of this point, and then you take the maximum one. So here what I wanted to say, in order to compute the what is called whether the point is outlier or not, what we are doing, first we are computing its neighbors, and then you are computing neighbors of neighbors, and then we are computing the what is called is reach distance. Once you got the LRD, and then we divide this, find using directly this formula, and then we'll get it. What in essentially what it is doing key with respect to it is computing one value. So what is the density of this region? What is the density of this region? And then with respect to this density, you treat this point. So therefore, nearby points, whatever will be the nearby points, so near with respect to the nearby density points, only this point will be considered as outlier or not. So therefore, this figure we showed earlier here. Now to identify whether this point is outlier or not, it is not considering this set of points. Earlier, what we do it, we should see the k nearest neighbor value. So now what we'll do it to identify whether this point is outlier or not. What we do it from here to here. We compute within the k nearest neighbor, and within k nearest neighbor again k nearest neighbor, and then we identify the points. So therefore, this is most or more robust than the earlier technique. So I am referring this paper here. So if you are interested, you can see directly. Okay. So I hope you will have many doubts. Okay. So is it right that you have many doubts? Or if you don't have doubts, then I will stop here, and next class will be the last class for this course. Okay. So next either in tomorrow or maybe Thursday. So I will accordingly I will inform you. So and syllabus is still today. Okay. Okay, I stop at this point. Yeah, Chinmay, you wanted to say anything?
I wanted to say that you could provide the link to this paper or upload the paper also.
Yeah, I cannot upload. I will definitely share the paper. Okay.
Thank you, sir.
And then finally you have to do project, right? Chinmay and then Pradhan.
Yes,
Okay.
sir.
Don't forget that.
Yes, sir.
Yes,
Social now, I think I do not see her. Anyway,
Yes, sir.
Rosan,
I'm here.
Rosan, don't forget. And horse, I did not get any information from horse. Okay, I stop here.